I appreciate that you guys are here. I'm a little concerned about everybody else. Here we go. Here come some people. Any questions from homework or anything else? Any questions?
I actually do have a question.
Yes.
So on 2.8, like just the last question, it's like the homework, like figuring out like the average. Like that's the only question I have left. I was wondering if you could go over that.
All right, let me see. Oh, shit, I passed it. Here we go. The last question.
Yeah, question 9.
Oh, yeah. Okay.
That's the only one I have an issue with.
All right. So somebody else asked me this question a while back. I can't remember if it was during office hours, probably. Um, the authors have a very strange sense of humor, but okay. So what was the student's overall average? So 40% of their average will be made up of their tests, right? So the very first thing you want to do is you want to average these. So let me show you what you're going to want to do. I'll do the first couple of steps, and then you can finish out the rest of it. Hold on, let me get this set up. Old man with technology. Everybody just hold on. All right. Okay, here we go. All right. So do you remember this whole idea of setting up a table like this? So then I can multiply across and add down. Does that
Yeah, I
sound?
think so.
Yeah. So like the if you average these, could somebody take a second and average those grades? What would you get? Let's see. 90, 70, 80, 80, 83, 81, 81, 81, 80. So it'd be 80.75. I don't know. I'm doing that in my head.
Yeah, that's what I got.
Dude. Anybody impressed? No, it's okay. All right. And what's the percentage of this that goes towards the grade? What would go here for that, for the tests?
40?
40. I love it. So 0.4, right? And then the quiz, you're not going to put 140 here, right? What's the actual grade on the quiz? You would just have to do this division. And the same thing here, and the same thing here. And then this one, you'd have to average those. Right? So the project, for example, 38 out of 50 is 76%. Is that cool? 50 out of 50 is obviously 100%. And then you average these. Right? So you basically do exactly what we just did for the tests. See, here's the test entry, right? That's the test entry. That's the test average and how much the tests are weighted. Now do the quizzes. So they're going to be weighted 20%. What did you get for the quiz grade? You would put that right here. Is that all right? You guys okay out there? Hopefully several of you are just fine because a lot of you have turned this homework in. So
Yeah, I think I got it now. Thank you.
okay. All right. Like everybody else okay? Any other questions about that problem? Okay. All right. Anything else? Has anyone tried chapter 3 yet? You're like, no, dude, that's not due for a while.
No,
So huh? No,
not yet.
Oh, I see. All right. I have not been there yet. Anyway, sorry. Somebody's telling me they're out of the country, so their internet will be laggy. So I understand. Let's see. Okay. Everything else is good. Any other questions before we get back into where we left off? So one other thing I want to say real quick. Hopefully you guys are paying attention to your grades. Most of you guys are passing. Some of you guys are not quite passing. if you want to know what your grade would be once you make corrections to midterm, because the midterm is the heaviest weighted thing currently. So if you make corrections to the midterm, that could pick your grade up quite a bit. You guys with me? So you can make corrections to the midterm just like you make corrections to the quizzes. I like it. So you just have to like email me or come to office hours. I can tell you what your average would be if you got all the points back on the corrections for the midterm. All right. Okay, all right. So we're gonna get back into where we left off. I kind of want to try. All right, I'm gonna do a couple of things to close out section 3.1. And then we're gonna get into 3.2 a bit. So let me try something up here on the board. I've got to go to the campus at some point because I still don't have all my files. So I was hoping to have some more worksheets, but I don't have them here with me at home. Oh, so let me try this. Uh-oh. All right, guys. Now, I really want you to trust this slope formula that we've got. I really want you to trust it. All right. Oh, my lighting is still weird, but I will. So we'll do that. That's too low. All right, we'll work. So let's say I've got 2 points. I'm not even going to give us a scale or anything. Let's say I have a point here. Let's say this point is 1, 3, and I have a point here, and let's say this point is 5, 7. So it's 1, 3, 5, 7. So all right, just go with me. So this is not the way I would want you to give me a graph. Oh, sorry, Genius, you got a question?
Yeah, sorry. My phone is lagging a little bit. This is section 3.0 or 3.1?
3.1, yeah, 3.1.
3.1. Okay, thank you.
Okay. Now, slope is how much I rise while I run a certain amount. I really want this to make sense. So mountain, if I'm doing hiking and I have this slope, that's okay. If I have this slope, holy shit. So slope is all about how much do I move over as I move up? How much do I move over as I move up? So this is obviously less steep than this is. Does everybody agree with me? So the value of the slope must be bigger for this than it would be for this. So it kind of makes sense to match the physical situation that we know of as slope. I want the math to say it's how much do I run as I rise how much? Okay, maybe. Because what would flat be? Flat would be all run, no rise, right? Not all gas, no brakes. All run, no rise. So this would be no rise over run. So that would be flat is 0. That makes sense. Flat plane would be 0 slope. That makes sense. Okay, I like it. That's what flat should be, 0 slope. Okay, now we are exploring this equation right now. This is not something you're going to have to do, but if I draw sort of like a little triangle here, it sort of makes things a little bit easier to consider. I don't even know. Yeah, you can see that. There it is. How much do I run? How would you figure out how much I run since I can't count tick marks like we could if I gave you a full graph. How far is this?
3.
1.
All right. What's the X value here? What's the X value here?
1.
1. Is everybody cool, right? Isn't that the X value there? 1. What's the X value here?
5.
5. So how long is this?
4.
4. All right. Is everybody with me? So this
Yeah.
is 5. This is 1. So 5 minus 1, it's 4. It goes over 4. It was at 1, and now it's at 5. So obviously it went over 4. Is everybody with me? So what is this? I do the same thing, but now I'm going to look at the other part of this, right? So it was at 3, now it's at 7. So how much did it rise?
4 again.
Yeah. So then the slope is going to be rise over run. So this guy's slope is 1. It's positive, so it's going up as I read left to right, right? So if I put a line in here, that line is obviously going up. As I move from left to right, it's going up, and it goes at a rate of 1 step over for every 1 step up, 1 step over. So if I do 1 step over, 1 step up, 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 that's how it goes. That's how it moves. So if I had a slope of 2, it would be steeper. Slope of 2 would go 1 step over, 2 steps up, 1 step over, 2 steps up, 1 step over, 2 steps up. Be way the hell up there. Okay, maybe me. Now, how does this connect to the equation? Well, you can see how it connects. What was 7? Wasn't that the the Y piece of the second point? And 3 is the Y piece of the first point. So how do I really want this to make all the sense in the world. Slope is rise over run. How do I figure out how much it rises? I do the difference in the Y's. How different are the Y's? That will tell me how much it rose or fell if it's negative. So I take the difference, how different are the Y values, divided by how different are the X values. So this is really how much did the Y's change per how much did the X's change. That's a rate of change. I have no idea if you guys are with me or not.
Is there a difference between if we choose the first one, and the 3.1 and 3 is the x2 and y2, and this is the opposite about 5.2, 5.7, or
Sure. No. There isn't. All right, I love it. It's a beautiful question. So if I figured out this slope the other way, if I figured out this slope by doing 3 minus 7 divided by 1 minus 5, what's 3 minus 7?
-4.
What's 1 minus 5?
-4, yes. No, that's me, same.
The
Okay.
important thing. So I really, now stay with me now, guys. Stay with me. Come on. All right. This is so beautiful. What the shit are these here for? Why the flippin' shit are those there, right? If the idea is just take the difference in the Y's and the difference in the X's, it's because if you do 7 minus 3, you must do 5 minus 1. You have to do the same direction. If you do 3 minus 7, you must do 1 minus 5. Otherwise, your slope has the wrong sign. It'll be negative when it's supposed to be positive. If I just look at this, can't I tell this is a positive slope? It's increasing. So my answer better be positive no matter which way I look at it. I like it. So all slope tells you how to do is if this is a path I'm supposed to be on, if I go over 1, the slope tells me to go up 1 and I'm back on the path. If I go over 1, the slope says go up 1, you're back on the path. But look at this. Isn't this really, are you guys cool if I put this as -1 over -1? I know this kind of stupid. You would never do that, but could I? Do you guys see that? Is this wrong? It's like not done, but is it wrong? No, it's just not done. When the next step I would say it equals 1, of course, right? Stay with me. But watch this. Physically, what does this mean? This means go down 1, back 1, down 1, back 1. I'm still on the frickin' line. So if I can leave my house and go to somebody else's house, I better be able to get freaking back to my house, right? So slope doesn't care which direction you're traveling. It still works. If I'm going from my house to my friend's house, over, up, over, up. If I'm coming back home, down, back, and then I get back home. All right, no idea. So let's rein this back in. Let's do a very specific example. Let me erase all this. So I don't know why you're so shaky. What is wrong with you? I have no idea. All right. Let's see. All right. So find the slope between the points. So what if I have 7, 1, and what do you got, Jeff? 4, 7. I like it. So if you need to, pick a point and call it x1, y1, right? And the other point would be x2, y2. Now, like we just saw a minute ago, a very good question was, does it matter which one you consider to be the first point? No. It doesn't. It wouldn't matter. If I switch them around, I get the same answer at the end. All right. So now the equation for slope, oops, I haven't said that yet. So slope, let me go ahead and make this official. The variable we use for slope is the letter M. And real quick, we don't know if this is true or not, to be honest, but we think that the reason it's M is because of the French word marcher for walk. Isn't the slope telling you how to walk? So that's why they think maybe that's why the letter for slope isn't S, it's M. Are you guys, has anyone ever wondered why the hell is the letter M for slope? They think that's why. It's funny that we don't know for sure. So now, since I've identified what these are for me, y2 is 7, y1 is 1, x2 is 4, x1 is 7.
Six over -3.
Yes, 6 over -3, which is?
-2.
Like. Now, what if you had instead, what if you had called this one x2, y2, and this one x1, y1? Well, it would have been y2 minus y1, 1 minus 7 over x2 minus x1, 7 minus 4. It would have been -6 over 3, which is still -2. Okay, maybe. So the slope of a line doesn't care which direction you're traveling on the line. Just because you're coming from here back doesn't mean the slope is negative now. It's still, if it's like this, it's still going to be a positive slope. All right. You guys okay out there? I forgot to check my Wi-Fi, so I keep looking at the people I can see to see if you look frozen. And you're all very... Okay. All right. So here, you guys try this one. Let me leave that up here. You guys figure out the slope between these points. All right, so now we're doing this. Figure out the slope between those. Is that too faint? Probably. Poor green. So I really want you guys to get to the point where the formula doesn't get in your way. This really doesn't matter. It was a really good question a minute ago. This formula doesn't really matter. The reason that this formula is necessary is just to remind us we have to do things in the same order. So if I do 2 minus 9 for the y's, I have to start here, 11 minus 4 for the x's. That's all that formula really is there for. Yeah. So then you get negative 7 over 7, which is negative 1. And sure enough, if you plot the points 4, 9, I'm just going to do really roughly. 4, 9, and 11, 2, wouldn't that be a negative slope? Yes, it makes sense. It's a negative slope. 4, 9 to 11, 2 is a negative slope. It's going to go down. So that makes sense. Okay, maybe. All right, one more thing I want to say about this. I'm going to erase this now. So real quick, if I only give you points and I ask you for the slope, you do not have to graph it. Don't graph it. Use the formula. Now, if I do give you a graph, so if I said find the slope, oh yeah, that's right, you gotta do some negatives. I've been avoiding negatives, but we'll do it in a minute. Sure. For telling you that's a straight line. Okay. So what I can do if I've got this is I can just count, right? So slope is rise over run. So how much do I go up from this point and then over? How much do I go up?
3.
No.
2.
2, right? Don't I go up 1,
Mhm.
2? And then how much do I go over?
4.
4. So this slope would be 1/2. What if I had gone the other way? If I start here? So this is kind of like related to switching the x and the y when we do the slope. Remember, it doesn't matter which point you start at. What if I start here? How much do I go down?
2.
Yeah, so I go down 2, right? That down means negative. And then how much do I go back?
-4.
Yes. Isn't that still freaking 1/2, correct? Isn't that kind of neat? But not really, to be honest, but still, it's kind of neat. No matter which way you look at it, you get the same answer at the end. It is a positive slope line. It shouldn't change just because I went from one house to the other instead of the other way around. Okay, maybe. Very hopeful. Okay, so let's do one more of these because I kind of avoided negatives for a little bit. So what if I had these 2 points? All right. Find the slope between those 2 points. Nothing changes. You do the exact same thing that you just did. Just because there's negatives doesn't change anything. All right, so
-2 plus 5, because minus and minus is plus.
stop. You just mixed y with x. No good.
Oh, yeah.
Be very careful. Y's got to go with y. So -2 minus 1, that's the y's, over
-3 minus a -5.
Yeah, so don't feel like I already put a minus. Why would I put another minus? Because it is minus. It's negative, right? So nothing changes. You still subtract, and you put one number here, and you put the other number there, with a subtraction in the middle. So this would be -3 over.
And a +2 under.
Yep. Now, if you had done it the other way, so you get that, where you do 1 minus -2, 1 minus -2. So I'm going this way. So then I do -5 minus -3. I would have gotten 3 over -2, which is the same thing. Become a 3. Okay. I like it. So how much you rise is the difference in the y's. That makes sense. Why did I rise 2 here? Because 3 minus 1 is 2. Why did I run 4 here? Because 5 minus 1 is 4. All right, so that makes sense. If the rise over the run, so the change in y's over the change in x's. Okay, I like it. Okay. All right, so that's, let me think. There was something else. I can't remember now. What was it I wanted to do? All right, I gotta remember. Let's look at the book real quick. See if we can transition to 3-2.
Excuse me.
Yes.
Before you go to 3-2, can you check something? Can you do something like number 6
All right, let's see.
on 3-1 application?
Here we go. 6. Oh, okay. All right. How much do I want to do here? So this one, all right. So this one, it kind of depends on how you've done the first 5 questions. So if you agree on a price of 23,000, the one thing I want you to realize. So this problem is all about, depending on how much money you borrow, the amount you're going to pay per month will change, right? If you're going to borrow more money, you're going to have to pay back more money. So what this table does is if for every $1,000 I've got to pay 2209, you can just fill in the rest of this table, right? Number 6 says, if you agree on a price of $23,900, but they offer you $7,500 in trade-in for your old car. So how much money are you actually going to owe them now?
16,400.
Good. So 16,400, how much will your monthly payment be for that? That's what you've got to figure out.
Actually, I stuck here.
All right. So I kind of don't want to say too much about this until everybody's had a chance to try it, because it's not immediately obvious how you do this. So you have to think about how you're going to, and the reason you're having trouble is because it's not a whole number, right?
Yes.
Okay. So I don't want to say too much yet. I want people to try this out. I want to see what people come up with as to how to figure this out. I'm really
Okay.
sorry. You're like, well, damn it, Jeff. I don't know. I've tried. I'm like, all right, just wait. Just
Okay.
Okay. So just
Thank
leave that one blank for now. We'll bring it back up when more people get there, because now it goes to a different problem. Okay. All right. I like it. So let's look at. Yeah, let's look at this here. This, I know I'm kind of doing some of your homework here. Let me see where this starts. All right, that's easy enough. All right, but look at these problems. Look at these problems here. Does anyone have any issue with these? These should be pretty straightforward. Does anyone not understand what this is asking? How would you do part A here?
Input 35 for C.
Yeah, input 35 for C and then do it to figure out what K is. I love it. So those should not be a huge deal. Those are just substitute and then do the work. I like it. But that's the reason they have this here in the prep skills, is because the next section is all about expressions and simplifying expressions, right? And what the hell is an expression? All right. Well, an expression is this. This is an expression right here. C plus 273.15. Now, I kind of disagree with them a little bit. If only, all right, let me fix something for them. I kind of know what they mean, but this is sort of bad. They should not have this here. Because with that there, what is that officially? What would you call this thing? What kind of thing is that? I mean, what would you call it? Let me see. How do I? It's not just an expression. An equation. That's an equation. Period. End of story. That is an equation. So this is the book being kind of silly. They should not have put that there. This is an expression. So an expression is just a mixture of variables and numbers with no equal sign. That's an expression. An equation is when I equate two expressions. All right. I know that we're getting in the weeds a little bit with the definitions and stuff. Okay. Clear that away. So we're going to try to make a connection here between what we've been doing graphically with formulas and equations and expressions. And I know when I put the letter M, and I don't know if I've said this yet, does anyone remember the equation of a line? What's the equation of a line? Y equals something with M in it. There could be a B in it.
Y
MX
equals
plus B.
mx plus b.
MX plus B, I love it. So we're slowly working towards that. So section 3.1 was all about M. What the hell is M? What the shit is M? M, right? Section 3.2 is all about, okay, now let's talk about expressions and what they capture. And then we're going to try to merge those together to get an equation of a line. All right. So let's see. All right. So this, I don't really appreciate this too much, but let's try this problem out. They have a snow cone fetish. I don't know what that's about. They just love snow cones in this book. But we'll work through it. So look here, number 2. Let's try to read this thing. Does anyone know what this kind of thing is from? Has anyone ever used this software?
Just Excel.
Yeah, Excel. It's just a spreadsheet, right? Could be Excel, could be, any number of database stuff. If 300 snow cones are sold, how many ounces of syrup do you need for those? There's a lot of information up there, but what columns am I looking at?
Yeah.
Number of sow cones sold and the syrup in ounces.
Mhm.
Good. So I'm looking at these two. So if 300 are sold, I need how many ounces of syrup?
600.
600. If 500 snow cones are sold, how many ounces of syrup do I need?
1,000.
1,000. I love it. Can you right now, if I call the number of snow cones, I have no idea if they're going to do this later. The number of cones sold, let's call it C. Isn't that crazy? Can you write an expression for how much syrup I need? What seems to be true? When I want 300 snow cones, I need 600 ounces of syrup. When I want 500 snow cones, I need 1,000 ounces of syrup. When I want 400 snow cones, I need 800 ounces of syrup. So what seems to be the connection? Whatever number of snow cones I
Double.
need,
Double.
It doubles.
double. So what's the amount of syrup I need if I want C cones? If I want the number of cones I want is C, how much syrup do I need in ounces?
200.
C
No.
times 2.
200 would be if C was exactly 100. I am just saying any amount of snow cones. Any amount of snow cones. How do I figure out how much syrup? I heard
Times
somebody
2.
say it. 2C. All right, let me stop for a minute. I know we're not talking about anything overly exciting right now. Snow cones, whoop-de-doo. But this is the point of algebra. This is the point of algebra right here. Holy shit. Somebody's finally telling you the point of freaking algebra. It is if I want to know in general what the shit to do. So if it could be any number of cones, is there something that I always do to figure out how much syrup? Yeah, I just double the number of cones. So that relationship is caught right here. So I can make an equation now. What letter do you guys want to use for ounces of syrup? I don't know. What letter do you want to use for ounces of syrup?
Yes.
All right, I like it. I like most of you guys are like, I ain't gonna say it. Whatever, Jeff. Whatever. So I could now make an equation and say ounces of syrup is equal to twice the number of cones. Ooh. So that's where equations come from. They capture relationships between variables. That's all equations do. They capture relationships between variables. Okay. So it seems very simple, but I really want you guys to see this is all algebra really is built on. This isn't all algebra is. You know that's not true because you've gone through algebra. You know what the shit, it's got a lot of shit going on. But this is the building block of algebra. All right, I'll stop. Let me see. Let me clear all this away. I have no idea what's going on with my voice. Hold on. Oh, okay. Let's see. All right, this is dumb. Number 3, we basically did what number 3 is saying. And they're saying it in really weird ways, but they really just wanted that equation. D5 is the amount of syrup. So how do I figure out how much syrup given the number of cones? S equals 2C. We figured that out. That's what number 3 wants. All right, I don't care about number 4. I don't care about number 5. Okay. Oh, see, they use the letter S. Isn't that crazy? All right, so it took them forever just to get to that. S equals 2C. All right, so let me look at number 7. Let me remind us what the formula was. The formula was syrup in ounces is twice the number of snow cones. So does the number of snow cones depend on the amount of syrup, or the other way around? Does the amount of syrup depend on the number of snow cones? The way that we've written this formula, which way? What do you guys think?
The syrup
depends on the snow
depends on
cones.
the snow cones sold.
Good. I think both you guys, somebody else was saying this in concert with you. Yes, it's this one. The amount of syrup depends on, because syrup is twice cones. So the syrup depends on the number of cones. I like it. Another way to say this in mathematics is syrup is a function of number of cones. If you came into this class wondering how complicated Jeff could make snow cones, you now know. Okay. Just wanted to let you know that the question has been answered. Now look at number 8. We basically just gave this away a little bit. Let's see. In the formula up here, which is the independent variable, which is the input, and which is the dependent variable, which is the output? What's the input?
The amount of syrup.
No. So up here, what did we say? The amount of syrup depends on, so isn't the syrup the dependent variable?
The number of snow cones?
Yes. So wouldn't I input a number of snow cones and then double it to get the amount of syrup to come out?
Oh.
So that would be
Yes.
the output. So the output is syrup and the input is cones. So we've looked at this idea before, input versus output, dependent versus independent. Now, number 9 should be pretty obvious. Is this linear, exponential, or neither? The relationship.
Linear.
Linear. I love it. Okay, I like it. All right, let me clear this away. Clear. Whoa. Sorry. Oh, who cares? All right. Blah, 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 blah. Who cares? I've kind of lost interest in this problem. Hold on. Oh, let's go to the group work. I think this gets more interesting. All right. Yes, this is much better. All right, guys. This one now is going to focus on the intercepts at first. So they have graphed. I really want to, let me go back up here. So do you see at the end, why, if they sold no snow cones, why would their profit be negative? So what goes into profit? Don't worry. I don't like business. I never want to teach business. I'm sorry. I'm making people want snow cones. But this is a very, very, very simple idea in business. What makes profit? How do you get profit? So I'm going to have an amount of money that I make. That's my revenue. But is all that profit?
No, because
No.
you still have your
No.
expense.
I got to subtract my costs, right?
Yeah.
Profit is revenue minus costs. So yeah, so if you sell a couple of lemonades at your lemonade stand, you might not have done something like what happens if my profit is 0? Does anyone know? See how the profit's going to be 0 in between here somewhere? Do you guys know what we call that point?
Breaking even.
Yeah, break even point. Right? So breaking even means you've made no money, but for a business, the break even point is a huge milestone to reach. Yes, once you reach that milestone, then you're ready to make money. And before that, you're losing money. So, it's a good thing to reach. All right. So let me come back down here. So they took this information, the profit versus the number of snow cones, and they just graphed those. No big deal, right? They just graphed those points. There they are. Woohoo! So what's the y-intercept? So here's the y-axis, right? Here's the x-axis. What's the y-intercept? Just remind you, it's a point.
Negative 250.
Now they're a little more specific on the graph. You don't have to try to estimate. And it's a point. Remember, so when I ask you for an intercept, the answer must be a point. So what's the,
Negative 245.
all right, let me try again. That's not a
Negative
point.
0,
There.
comma, negative 245.
There we go. So, all right. And this is where students are like, all right, math teacher, what the shit, you got to be so picky. But intercepts are points. So if you give me a number answer to an intercept question, you have to be wrong. I really want you guys to understand. So I know you know what you're talking about when you say negative 245. I'm not going to take 1,000,000 points off, but you're going to lose some points because the intercept is a point. Okay. I like it. What the hell does it mean? Don't say anything yet. Everybody think for a minute about what is the X? Let me see. You can answer this question. What does the X represent in this problem? Physically, what does the X represent? What is this?
The number of snow cones sold.
Good. X is the number of snow cones sold. I like it. And what's the Y represent?
The profit.
All right, now don't say anything. Think about it for just a minute. Physically, don't say anything. Physically, what does that point mean? Think about it for just a minute here, or a few seconds. Okay, who's got it? Can somebody tell me in a sentence what that means in the real world, that point? Here, I'll start the sentence off. When you sell, or let's say when we sell, how many snow cones?
Sell X amount of snow cones.
No, come on, be very specific. This is a
Okay.
specific
Zero
point.
amount of snow cones, we lose $245.
I lost you there. What's up?
When we
You
sell
sell
0
zero.
snow cones.
Yeah, when we sell no snow cones or 0 snow cones,
We lose $245 today.
we lose $245. Ah,
That sucks.
yeah. And can somebody even go further? Okay, that's the direct translation from math point to sentence, right? That's the direct translation. Now let me go one step further. What does the negative 245 represent then?
Loss in profit.
Say again, sorry.
Loss in profit.
True. But
Go
what
even
must,
further.
say again, sorry.
Go further.
Further, yes. So what does it take to set this business up? What do they have to do to get this business
Oh,
going?
it takes 245.
Yes? So the $245 was the cost it took to set the business up, right? $245 probably in materials and whatever else. You with me? Some advertising. You guys okay out there?
So it takes $490 to make a profit. I don't know. Sorry.
You're all right. So yeah, so it cost them this much money. So until they pull in this much money, they are losing money. That's how much it costs to set the thing up. Okay, so every business starts in the negative because you had to spend money to get it set up. All right, what about the X-Intercept? What's the X-Intercept?
389,0.
All right, and what does that represent? You can actually tell me in a little phrase, or you can tell me more directly what it translates into. So let's start off with the direct translation. When we sell, how many cones?
Snow cones.
389 cones.
We break even.
We make, oh, I like it. We make $0. And another quick way to say it is break even point. Holy crap. Break even point. There we go. I like it. So by the way, not every situation we look at graphically is going to be profit and revenue and cost and all that kind of bullshit. We're going to look at all kinds of graphs that have different physical interpretations. We're not going to suddenly become a business class, okay? This is very, very intro level business anyway, so none of us are going to go insane, or any more insane than we've already gone. Is everybody with me so far? So finding the y-intercept and the x-intercept is relatively easy. You just got to find the points that hit those axes. That's easy. Physically interpreting what they mean is another kind of level, right? So here, that's what these mean. In this case, break-even point, total cost at the beginning, all that kind of stuff, because that's what this graph represented. So let me clear all this away. Here it goes. Clear. Now, how do I do this? All right. Find the slope of the line. Take a minute and find the slope. I'm not even going to tell you anything. Just find the slope. Don't say anything. Let me remind you guys of a few things. Will the slope of the line change if you pick different points? Anybody? Would the slope of the line change if I pick different points?
No.
If it did change, that would mean it's not a straight line, right? It would have to suddenly change slope somewhere. It would have to curve. So what that means is, does it matter which points you pick to calculate the slope?
No.
Nope. And you got a ton of points, so just pick a couple. Pick a couple points. There are 2 points that are better to pick, and I'm going to pick them, but let's see what you guys pick. I don't know. Can you predict for me? Some of you guys might have done it already, but should this slope be positive or negative?
Positive.
Positive, because it's going up. I like it. So that's good for business if I'm actually moving in this direction. So what points Can somebody tell me what points they used? Did anybody pick points? What points did you use? Did anybody do this? Does anyone know what's going on?
Yes, sir. We're supposed to be graphing, or not graphing, finding the slope of this line.
Yep. And to do that, you have to first pick 2 points. So can somebody tell me?
Picked the X-intercept and then the next point up, which was the 570.
Oh, wait a minute. Oh, the X-intercept. I'm sorry. Misheard you.
The
You picked the X-intercept and the next point up.
yes.
Cool. So let's see. So if I do that, let me write them here. So if I do that, I could do 70 minus 0. I like it. Divided by
500 minus 389.
I like it. So you get 70 over 111, right? And let's take that one more step. Go ahead and divide that and tell me what freaky decimal you get. Those are points.
0.630630.
Ooh, neato. Blah, blah, blah. Okay, I like it. So help me out here. What are the units on this slope? This is where people freak out a little bit, but what's the y-axis? What are these here? What units do these have? What's the y-axis?
That's snow cones. Is that a unit?
No.
No.
Y-axis.
Oh,
Dollars?
it's dollars.
Dollars. And of course the x-axis down here. These are
Snow cones.
snow cones. So for every 111 snow cones, how much money do I make? Profit goes up by how much?
$70.
So every 111 snow cones, I make another $70. Now, stay with me now. If I do this, if I go to this step, right? There's still a bottom. It's just what's going to be on the bottom now that is going to be 1. So we've basically made this a unit thing. So again, what's the top? The top is dollars and the bottom is cones. So I make 63 cents more in profit every time I sell 1 more cone. You guys with me out there? That certainly would be a great thing to know, because then I could try to plan my business out better if I know that basic fact. I'm sorry, go ahead. Somebody had a question? Anybody? You guys all right? Okay. All right, let me clear this away. Somebody keep that written down somewhere. Let's see, clear all this away. It's going to go away, bam. All right, estimate the profit if 150 snow cones are sold. So we can do that pretty simply. If I sell 150 snow cones, how would you estimate the profit? Where's 150 snow cones on this graph?
So we could, it's
Multiply that 63 cents by.
Oh,
1
sure. We're going to do that in a minute. So you're ahead of me. I just want to do it graphically first.
if we sold 150 snow cones, we would be around negative $150.
I like it. So do you guys all see that? So 100 snow cones, I'm at negative 182. 200 snow cones, I'm at negative 119. So I can estimate 150 would be about right here. And if I go down, that looks to be about negative 150 in profit, which is a neat coincidence, but that's all right. So if 150 snow cones are sold, I am losing 150 bucks. I've made back some of my money I spent, but not all of it. Okay, I like it. I like it. How much do you need? How much do you need to sell to make 50 bucks? So now which way are you looking at it? Where's 50 bucks? 50 bucks is here. So now if you look over, how many snow cones do I need to sell to make 50 bucks profit?
Between 0 and 70. Yeah.
No. Here's 50 bucks. Now how many snow cones do I need to sell?
475.
Yeah, about 475. If I sell 400 bucks, I break even. If I sell 400 cones, I break even. If I sell 500 cones, I make 70 bucks. So somewhere between 400 and 500, it looks to be about maybe 475. I'll make 50 bucks. Okay, maybe. All right, so right now, so somebody was trying to tell me to do it algebraically, which I love just a minute ago. We're not quite ready for that because we haven't officially gotten to the point where I can put the equation together yet, but we can graphically estimate some stuff. Okay, I like it. Oh, okay, now we're gonna, all right, here's where it happens. So let's see. Oh shit. All right, here we go. Fill in the blanks. The profit starts at what when those snow cones are sold? So what's the profit start at?
Negative 245.
Good. So the profit starts at negative 245. Dadgummit. Hold on. Stay with me now. Stay with me. I know today's boring as hell, but just stay with me. Profit starts at negative 245 when those snow cones are sold and goes up by, we just figured this out a minute ago. Now come in with that. For each snow cone I sell, how much money do I make?
63 cents.
Yeah, roughly 63 cents. Okay, now, how do I make an equation out of that? Okay. Let's see if you guys are cool with this. So it starts at negative 245 and it goes up by 63 cents for every sale. So can somebody help me out? What if I sold 100 snow cones? Not looking at the graph, but just looking at the numbers here. How would you figure out how much my profit would be? So I start at negative 245 and it goes up by 63 cents for every cone I sell. So if I sell 100 cones,
You would multiply.
$63.
all right. Yeah,
You would multiply 100 by 63 cents,
good.
and you would get $63.
Sure, but that's not how much my profit is. Not at all.
You would have to subtract that from your negative 245.
Yeah, so you start at negative 245 and you go up by 63 cents per cone. So what's that? Anybody? Is it negative 182? Is that what that is?
Yes.
Thank you. And if you look at the graph, what's the point 100 comma what?
It was 100, 182.
It's going up, increasing.
But the point is, didn't we just
Negative.
calculate the same thing that where the point is, right? I mean, that's
Yes.
okay. So here's the connection then between points on a graph and algebraically what's going on, right? So, all right. So this is what it was for 100 cones. What would I do if it was 200 cones? Would I do anything really different?
Change the number.
No,
Of
just to change 100
So
to
I'd
200.
start here and I would add 0.63 for every cone. So now that's 200. Right? So now that's gonna be negative 119, is that right? Nobody can help. All right.
It's negative 119.
Okay. So negative $119. So all right, now stay with me now. Stay with me. What if I sold X cones? Meaning an unknown number of cones. What would my profit be? So this is always, I'm figuring out the profit each time I do this equation. Now capture the idea of what I'm doing. It doesn't matter if it's 100 or if it's 200 or 300 or if it's 7. What do I always do to figure out my profit? I start at negative 245 and I
Plus 0.63 times X.
there you go. I like it. That is the equation that governs my profit based on the number of snow cones. So this would be profit as a function of number of cones sold. All right. I love you guys. And look, isn't this slope times X plus, and the thing we're going to have to talk about is the y-intercept. We call it B. So isn't this mx plus b form? All right. Maybe I went too far. I don't know. Let me clear this away. Okay. All right. I think that's enough for today. What do you guys think? I think that's enough for today. So we're almost there. We almost got the connection between all the little things we can find in a graph and putting its equation together. So we still have to talk about more generally, how do I do it no matter what? Okay, but I think that's enough. We're basically almost out of time. So let me know if you need to hang out afterwards. Otherwise, you're free to go.
Thank you, sir.
Anytime.
I had a quick question.
Yeah.
So I'm just looking for it right now. We just did it in the group work, I believe. Yeah, I'm trying to locate it. I'm sorry, my bad.
What's up? Yeah, that's fine.
It was about the net profit one. I can't find it.
Net profit. Oh, here we go. Number 4, page 302.
302. That's what it is. Yes, I just had a hard time finding this other one.
Hard time doing what, sir?
That one, number 4.
Yeah, number 4.
Yeah, I couldn't really understand that one.
All right, so you're okay with the word net, right? That just they really didn't need to say the word net, to be honest.
So just profit.
Yeah, it's just profit. So it's nothing special. Net profit just means the total amount of profit you make.
And then you said that's revenue minus cost.
But you don't have to. The nice thing is we've already got all the answers. I don't have to kind of piece it together. They've already given me all the answers right here.
Oh, okay.
Right? So it's sort of like if this didn't exist, I'd have to put the formula together and then I could calculate points and then I could graph them. But somebody's already done that. So for 150 snow cones, 150 is about right here. Where is the output for an input at 150? It looks to be about negative 150.
Oh, okay. We're just kind of lining it up.
Yeah. So if I didn't have a graph, I got to plug the number into an equation to figure it out. If I do have a graph, this represents all the outputs I would get. So then I can just look at it and estimate. Yeah, it looks to be about, I lose $150.
Okay.
Yeah,
Okay, that's making sense.
I like it.
But when they ask for what's the significance of the sign, that one throws me off. Like,
Oh, well, I mean, what is it good or bad for your business if you do sell $150 and that means you're negative 150 profit? What's that negative mean? That's all.
$150.
There you go. You're losing, right? So negative means losing, positive means gaining in this case, right?
Okay.
That's all it means. The significance of the sign is that's not a good place to stop. You need to sell some more snow cones, right?
Right. Okay. Awesome. Thank you, Professor.
You're welcome.
All right, have a good one.
You're welcome. See you. Adeline, are you out there? All right, I think she's not really there. I'm gonna put her in the waiting room. All right, Daniela. Let me see. Let me stop